Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the paging in operating systems. Paging. It is a memory management scheme that permits the physical level addresses space of the process to be the non-contiguous. Next point, it avoids a considerable problem of fitting the varying the size memory chunks on the bankings too. Next one, basic method. Here we have that basic methods we defined as a pages and the frames. Pages. It divides the logical memory into the blocks of the same size is called the pages. Next one is the frames. That is divide the physical memory into the fixed sized blocks called the frames. The page size is the power of 2 between the 512 bytes and the 16 MB. Next one is the address translation schemes. The address generated by the CPU, that is logical address, is divided into the page number and the page offset. The page number is defined as the P used as an index into the page table, which contains the base address of the each page in the physical memory. Next one, page offset. We defined as the letter D. It combined with the base addresses to define the physical addresses. That is, physical address is equal to base address plus the offset. Next one, it is here we have the paging hardware followed by the paging model of the logical and the physical address. First one is the paging hardware. Here we have that CPU is connected with that P and D, that is paging address, and that here we have the two addresses, logical address and the physical addresses. It is interconnected with the page table. After that we have it goes to that physical memory automatically save under the physical memory. Next one we have that paging model of the logical and the physical memory. In logical memory we have the page 0, 1, 2 and 3. According to the page table, the intermediate we have the page table. According to the page table number, the memory allocation happens in the physical memory block. Uh, that the side we have the frame number. According to the frame number, the allocation will be happened. Next one will be the allocation. When the process arrives into the system, its size, that is expressed in pages, is examined. Each page of the process needs a one frame. Thus, if the process requires is equal to n pages, at least is equal to n frames must be available in the memory. If n frames are available, they are allocated to this arriving process. The first page of the process is loaded into one of the allocated frames and the frame number is put into the page table. Next one, repeat the above step and for the next pages and so on. Next one we have is a frame table. It is used to determine which frames are allocated, which frames are available, and how many total frames are there, and so on. That is, it contains all the information about the frames in the physical memory. Here we have the diagram of before allocation and the after allocation. Before allocation, we have the free frame list that contains some numbers. Inside that others we have the new processes. Next one, this is the physical memory and the logical memory. After the allocation, according to the empty frames, it allocated automatically. Next one will be the hardware implementation of the page table. This can be done in the several ways using the PTBR. Next one is TLB, that is page table based registers and the translation look aside buffer. The simplest case is the page table based register is an index to the point the page table. Next one is the translation look aside buffer. It is the fast lookup hardware cache. It contains recently or frequently used page table entries and it has the two parts, that is key and the value, and it is more expensive. Next one will be the paging hardware with the TLP. When the logical address is generated by the CPU, the page number is presented as a TLP. Here we have the TLP hit, TLP miss, and the hit ratio. Hit ratio, the percentage of the times that the particular page is found in the TLP. For example, hit ratio is 80. That means the desired page number and the TLP is 80 percentage of the time. Next one, effective access time. Here we have calculated the effective access time as that 20 plus 100 plus 100, that is 220 ns, that is we defined as a TLP miss, and then effective access time, that is 0.80 into 120 plus 20 into 220, that is 140 ns. Thank you.